So we are going to be doing a Collatz and Fibonacci design. So we're going to form our first few pieces. Now that we have those first few pieces, we can come down our circular sector. We're going to start here. We're going to come down. We're going to start here. Come down. Now we have two, but if you notice, we have 1, 2, 3. We just share one. We now do a movement that allows it to be seen as 1, 2, 3, but we have an extra +1 movement that actually goes once again over our original movement. Now, this is one full movement where before we were using half measures. We have another movement, and then we have another movement. Now, if we want to bring out what I like to call the scorpion tail, we do our opposite corners, repeating what we had done before, just sending opposite corners, and then we, from this point, can take our segment system and draw segments. Now what we're working with here is Fibonacci, but there's a lot of things within Fibonacci. So one thing that I've noticed is it really depends on where we put our midpoint on what we create, and this will affect our total point by point system. Now if we want to go even better, we can actually midpoint all points used, drawing a web of interconnectivity. This will give us certain aspects that can then be related to each other in pretty interesting ways. Now we don't have similar on this side, so what we're going to do is use these to create a relative difference system that allows us to test projections in a 2D form. We can use 2D to be an exact, almost exact replica of 3D, not 3D, 4D. Odds repeat, evens repeat. So because of odd and even number phasing, which I can show you a relation to that as well, that will allow us to take advantage to test dimensions fully, with our only hiccup being our inventiveness and our ways of testing, because then we can always cross-reference for patterns between different methodologies and really show the interconnected web of full mathematics without assumptions based on personal viewpoints. We can let the numbers speak for themselves. I got a lot of images, so finding the right one that's needed can take a moment. I didn't have them separated or anything, but physics should boil down to not our own personal interpretations, but what the systems themselves speak for. And we can't really make a determinant on what kind of universe we are until we understand the realm of possibilities of systems. So whenever we have people that make decisions based on said limited data and interpretations, this can create a system that we have to actually fight back to actually show the proper. And that's not science. Whenever we're having to defend our position up against people who we can no longer convince our theory holds value, but they still hold value to other scientists, you know, it's a problem of idolization of a system. So this is our odds, evens, odds, evens. We get a phasing system, meaning we have binary dispersion, and then we have a repeating process, meaning we don't have binary dispersion. If we pay attention to 3x mod 3, we have an we have a wavelength. Odds, evens, odds is up, down, up. Evens, odds, evens is down, up, down. These are two wavelengths that represent a particle. So binary isn't enough. Trinary isn't enough. We actually have to get into what would be 4x patternizations, meaning if we have past, present, future, we need to look at the opposite of future, past, present. These things recombine to make a binary moment universe. It's not just the binary that matters. It's not just the trinary that matters, like charge, spin, and mass, where charge and spin are both active energies. That's a binary inserted into binary to cause trinary. Well, what we're looking at is actually the 3x minimal to set our wavelength, to set our particles, because our particle is actually, if wavelength is 3x, we can see 3 and 3, 3 and 3. There's no off balance here in 3x. There's a little bit of off balance here only because it's 4x, and 4x is naturally built to off balance in a 3D space. So we actually have to pass by the 4x to the 6x because of 3 dimensions and 2 rays. We have 6x energy per mass energy per, particle unit pushed. We have to. It's simple expansion. Now, a universe's expansion is starts in binary. We have matter to antimatter, like we have energy to mass, like we have up to down or clockwise to counterclockwise. These things combine to create a system that allows expansion. But a universe's expansion being binary automatically sets up for the simplistic ray system, which then evolves into our 3D matrix. I hope that helps you understand how Collatz and Fibonacci are actually both the same expansion system, simply because whenever we come back here, we're gonna we don't want to redo or undo. We want algebra. We're going to turn off some of these circles. Actually, we're going to turn them all off for the moment, so we can okay. Now we can go ahead and turn polygons off. We don't want to edit the polygon. Sorry if this takes a while. I'm not used to working just one side of the screen. Okay, we can go ahead and go back to tools. Bring that down. We're going to use this. So we're going to say this is our moment of time. We're going to say that this is our adjusted moment of time. Wait, no. I did that wrong. That is not the correct one. That is. Okay. So adjusted. And then we have our squared. Now, this point we have our full, but we actually have within our system the ability to show our 3x system, 3x plus 1 actually, is actually just by the end of settings, color, blue, on the right thing. No, I'm not. Get a load trying to do this with not the right one, not the right one, right one. Make that one green. There's a reason I make these green. In the middle, and that's because what we actually have is energy on one side, mass on the other, but our equilibrium point. So we build by going this way, or even this way, and then we come back to center before we go back out. And basically we're just using the opposite as diameter to do that. I think 15 minutes is enough, so I hope this helps you understand kind of the notion behind Collatz and Fibonacci both. Have a great day. Welcome back. We're going to do a bit of a round 2. So what we're going to be doing is trying to, we'll call it trying to prop out a square or a cube from a 2D surface with it fully mapped what they're showing us. So far we do not have anything out here to take, but we do have a bit of a corner system showing right here. Now, this is obviously some strange looking structure. It's not a cube in the traditional sense. But what we do have, though, is an ability to track out a, looks like parallelogram through 3 connected points outside of our traditional building rectangle, which that's what I'm building off of. I'm not stepping outside of the Fibonacci spiral that we have built and established, but we have tracking points that we can build off of the actual Fibonacci itself to track points outside of said area. If it's useful, we'll have to let the future show that. If it's known, I apologize if I'm just rambling on about something we already know. If it's not known, what can we do with it? What purpose can we get it to serve? Some more interesting things that I do see in here. We're going to go ahead and add a few points in this thing, and we're going to define what seems to be a pyramid there, which means we can also define said same pyramid, which is also a square base. So I call this a pyramid because we have our exact equilateral point already marked, meaning it's already being shown to us that that is more than likely a point, a convergent point of 2 non-exact 180 degree angle lines. So it's more than likely going to be our 90 because we know it's not that big. So it's kind of like this. It's all dependent on how big we see the projection off the 2D image as. If it's a small projection, then it's going to be greater than 90. If it's a large projection, meaning it's bigger than what it would normally seem to be, then it's going to be acute. That angle is that E angle, E to be a angle, or BEA angle, AEB angle. Now, one of the most interesting things about this that I'm seeing is the fact that we can draw this feels funny. The fact that we can draw yeah, this feels funny. A full full 3 squares, which would be 3 moments, which would be past, present, future, or electron, neutron, proton when equilibrium. So this is going to be working on a previous video. Yeah. So our 3 moments are here, here, and here. So we go back to our algebra. We can pull this up some, go all the way down. Okay. Settings, color, dark blue. Green. I'm going to turn it a little bit darker. Red. So, we can actually increase this time that we see here by pretty much we need a point there. We need a point there. Now we zoom out, grab a hold of that algebra, turn that line off, tools, okay, so this is where we're going to see something cool happen. So our newest little thing, not the point. We leave the point alone. We come up. And here we go. Green. Blue. If you haven't noticed, we are starting to show a lot of trends in the way that this builds. So, this is by far one of the coolest parts you will see in my work. We just have to get it approximate, because at this point it will be pretty easy to understand the notions. Now, we can use assumptions to take one moment of time And we're going to make it 9 moments of time through some impressive mathematical exchanges. So we're going to go ahead and color those two. Green, make it a little bit more darker. Green, make it a little bit more darker. Go back to algebra. Boom, 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 boom. Now, we're left with a choice on how to see this. But we're going to go with red. We keep our wavelength odd, even, odd, even, odd, even, odd, even, odd, even, odd for an infinite cycle. This is the 3x plus 1 system. 3x plus 1, 3x plus 1, 3x plus 1. It's all about timing and direction whenever it boils down to it. But how to show this on a regular numeric mathematical equation gets rather difficult. I hope you enjoyed, and I know it's chaos, but much of life is. That's why we got to treat each other extremely good. We got to treat each other like our actions are the things that matter most, or could matter most. I mean, you see how connected Fibonacci quickly becomes to Collatz, and how time can spiral out to create a new system. So how can you not see that your actions have a weight on other people? That's why we got to treat each other better. It's both for ourselves and each other. Have a great day.